The first question tells us that the point P minus 2 minus 5 lies on the curve with the equation y equals f of x, where x belongs to the set of real numbers. We're asked to find the point to which P is mapped when the curve with equation y equals f of x is transformed to the curve with equation, and the first one is y is equal to f of x plus 2. So we are given a curve f of x and a point P on the curve minus 2 minus 5. Assuming you are familiar with the rules of transformation of functions, well, the transformation of f of x to f of x plus 2 is the same as a vertical translation by 2 units upwards, and therefore in order to find the mapping of P on this translation, we simply need to add 2 to the y coordinate of P, and we get that P is minus 2 minus 3. For the next part, we are asked to find the mapping of P on the transformation y equals the modulus of f of x. So we have this point P minus 2 minus 5 on the curve f of x, and we need to find the mapping of P after we've taken the modulus of f of x. Now we don't know how f of x looks visually, so it would be impossible to figure out what the mapping is graphically. However, we do know what the definition of a modulus function is, and we can use that to find the mapping numerically. Now we know the modulus function is as follows. So say we have a function of x equal to x, then the modulus of that function f of x is a piecewise function, which basically just says that take the output of the function. If that output is greater than or equal to 0, then just return that output. And if the output is less than 0, then multiply that output by minus 1. Now in this case, we're looking at the outputs. So we're looking at the y value. We see that the y value is equal to minus 5. So based on our definition, since minus 5 is less than 0, we need to multiply this minus 5 by minus 1 in order to get the corresponding y value of P after the transformation. So therefore, transforming f of x onto the modulus of f of x gives us the corresponding mapping P minus 2 positive 5. Okay. The last part asks us to find the mapping of P after the transformation y is equal to 3f of x minus 2 plus 2. And this one's for 2 marks. So just by inspecting this transformation, well, we can see we have a transformation inside of the brackets and transformations outside of the brackets. So we know that the transformation is going to affect both the x and the y coordinates. So let's do this in stages, bearing in mind that we need to deal with transformations in the x-axis separately to transformations in the y-axis. So let's look at transformations in the x-axis. Given that we have the point P on the curve f of x, well, the x coordinates are going to be affected by the transformation f of x minus 2. From the rules of transformations, we should know that this corresponds to a horizontal translation to the right by 2 units, which means that we need to add 2 to the x coordinate of P to get the corresponding mapping of P equals 0 minus 5. So now we're done with the mapping of the x coordinates. Let's move on to the mapping of the y coordinates. Looking at the function, we can see that the y coordinate will be affected by 2 transformations, multiplying by 3 and adding 2. Now it's important to know that the order of transformation is very important, and the best way to think about the order is in terms of BIDMAS, where multiplication would always come before addition. So let's apply this transformation first. 3 multiplied by f of x minus 2. This is equivalent to a stretch in the y-axis, and it's done by multiplying each y coordinate by 3 units. So we need to multiply the y coordinate of P minus 5 by 3 to get the following: P equals 0 and negative 15. And finally, to complete the transformation, we need to add 2 units to the function, which is the same as a vertical translation. upwards by 2 units. So we need to add 2 to the y coordinate, which gives us p is equal to 0 and minus 13. So the point P after the mapping is equal to 0, minus 13. The key to remember in this question is that the order of transformation is very important. If at this stage we would have added 2 instead of multiplying by 3, well, adding 2 to minus 5 would have given us minus 3. And if we had then multiplied by 3, we would have got minus 9, which is the incorrect answer. Okay? If you like this video, please give us a thumbs up, leave your comments down below, and subscribe to this channel so you'll be the first to know when we release our next videos.